Alright guys, I'm just going to go through graphing data for you guys. Alright, so if you have a graph, most of the data that we record is all going to be positive. So we have just the first quadrant, just the positive part of a graph. Okay, and so 0 is down here, and the x-axis increases this way, y-axis increases this way. Okay? Whenever we graph in science, we're going to have to give our graph a title. And we like to use a scientific title that's associated with the independent and the dependent variables, or the manipulated variable and the responding variable. In this case, I'm going to make a graph of mass and volume. And this would associate with the lab that we did, where we measured the mass of different numbers of those little metal blocks. Since we choose how many blocks we put on the balance each time, we're in charge of the volume that we put on there. That makes volume the manipulated variable. Manipulated variable always goes on the x-axis. Okay, so we would write volume, and we would always include the units that we're using to measure that. In this case, we measured volume using milliliters. Okay, and we also want to label the vertical axis. In this case, vertical axis is mass. Let's see if I can write sideways on the screen here. And always, of course, we're going to include units with our graph on the axis. Okay. And then our title for the graph, and I like to put it up at the top, centered. The title for the graph is the effect of our manipulated variable on the responding variable. In this case, it's going to be something like the effect of volume on mass. Okay, once we have our graph labeled, including units for the vertical and horizontal axis, then we can plot our data points. But before we do that, we need to kind of scale our graph. So let's look at the volume measurements. It looks like the biggest is around 30 or so. So what we need to do is figure out how much each of these squares on the axis needs to correspond to. Okay, so let's count them. We got 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So if we just made each of those 1 milliliter, then we wouldn't be able to get anything past 21. We wouldn't be able to get our 2 volume measurements that are bigger than 21 on our graph. So why don't we make them count for 2 each? So I don't have to write every time how much it's going to be. I'm going to put just 2, 4, 6, 8, and then maybe just write occasionally, write what that's equal to. So 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. Okay, so what I did, I chose a scale for the graph so that the values would expand and fill up most of the space that I have available. All right, and I'm going to do the same thing for the vertical axis. I think I got 20 spaces here, 20 or 21 as well. So I'm going to have to choose a different scale for that graph. Let's see, if I've got 20 spaces, I need to get up to 136 or so, at least that big. So why don't I choose one like each of those is like 10 units. So that would be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Oh, I should have labeled which one is 50. 20, 30, 40, 50, 110, 120, 130, 140, 150, 160, 170, 180, 190, 200. Okay, so what I've done, I've chosen a scale where the graph fills up most of the screen, most of the space available for me. Okay, but I make sure that each of those blocks matches or is equal to the same thing. Okay, I can't go like 10, 20, 40, 80, 100, where each of those blocks represents a different amount. Each one of those has to represent the same amount. Okay. Once I've done that, I need to figure out where to put the points for my graph. Okay. So I'm going to take the first data point, 11.3, that's on the horizontal axis, so a little bit past 10, but not quite to past 11, but not to 12. So closer to the 12 than to the 10, but not much closer. And the volume there is above 40, above 45, just a little bit, so I'm going to put a data point about there for that first data point. Okay, so that corresponds to this data point, 11.3 on the horizontal axis, 45.32 on the vertical axis, and I had to estimate that. Okay, next data point is at 22.6, so a little bit past, there's 20, there's 22, a little bit past 22, and on the vertical axis it is past 90, just a little bit above 90. Okay, so I have to estimate about there. And that last data point, 33, above 32, a little bit past, halfway in between there is 33, so above 33. And my mass is above 100. See, there's 100, above 110, above 120, above 130, just a little bit, above 130, so about there. Okay, so now I've got my data points graphed. Oops, excuse me. All right, once I've done that, I want to kind of get a trend that shows what these data points are doing. I'm going to do that by adding a line. What I'm not going to do is connect those points dot to dot. Instead, what I'm going to do is draw a line that, as best as I can, goes through all of those data points. Some will be above, some will be below. This will be a little bit tricky for me on the screen. I might choose something like that. Okay. You can do that on your paper just with a ruler, a straight edge. You'd want some of the data points to be above, some of those data points to be below, but get as close to as many data points as you can. Okay? And that's how we produce our graphs for scientific graphs.